All right, class. Today's lesson is on solving quadratic equation using square roots. All right, and so the first thing it asks you is to graph the function f of x is equal to x plus 4 squared minus 1. So let's use Desmos and graph this, and let's answer the questions. So let me go to Desmos, and there we go. So let's graph this. Y is equal to, give me a second, guys. There you go. So we have y is equal to, parentheses, x plus 4, and that's raised to the power of 2 minus 1. Okay. So that's the graph right there. And what is a domain? Now remember I said before, it's a parabola with no restrictions on it. So the domain is going to be all real numbers. And what's the range? Well, let's see. Remember, range of y values. And the lowest point on this graph is -1. Right? That's -1 is lowest point of graph. And so there are no y values below the graph. All the y values are above. So therefore, the domain is going to be y is greater than or equal to -1. Okay. And I'm going to write this on the board in a second. And then what are the zeros? Remember, the zeros are where the graph crosses the x-axis. So let's look at this right now. So this is 2, this is 3. So 1 is -3 is 1, and the other one is -5. So -5 comma 0 is 1, and -3 comma 0 is the other one. Okay, so that's solving it algebraically. Let's go back and look at the. Let's put your answers on the smart board. So here we go. So we just graphed this algebraically, right? And you saw what the graph looks like. The domain is all real numbers. Okay. And if I can, I'm going to try to sketch this here real quick. So we know the zeros are -5. That's where the graph crosses the x-axis, and -3, which is right there. That's going to be really close. And then the vertex of this graph is -4, -1. -4, -1 is the vertex. All right, so the graph looks something like this. And you saw I just graphed it, but something like that. It looked like. All right. And so the domain is all real numbers. And the range we said, right? The lowest point of the graph is -1. That's the lowest point of the graph is -1. And so all the y values are above -1. So y is greater than or equal to -1. And what are zeros? We said the zeros are -5 and -3. And we can write that in coordinates as -5, 0, and -3, 0. Right? Are the zeros. Now let's solve this algebraically. Now, to do that, I'm going to back up for a second and just look at the square root of numbers. Now, in the past, when we took the square root of a number, say the square root of 4, right? In the past, we always get the answer as 2, positive 2. But in reality, there are 2 answers to the square root of 4. Right? There is a positive 2 and also a -2. Now, you must be saying, what is he talking about? Well, let's look at this. We know that 2 times 2 is 4. You all agree with that? And also, -2 times -2 is also is positive 4. All right. So when I take the square root of 4, getting a positive 2 and also a -2. Right. So when we take the square root of 4, there are two answers. There's a positive 2 and a -2. Right. But in the past, when you're asked the square root of 4, you always give positive 2 as the answer. So from now and in the future, when you take the square root of a positive number, there are two answers, a positive number and a negative number. So let's look at an example. What about the square root of 16? All right. Well, you always said the square root of 16 is 4. But in reality, there's also the square root of 16 is also -4. All right, two answers. Remember, -4 times -4 is 16. So if I take the square root of if I take the square root of 16, it's going to give me a -4 too. So, all right. Now, we usually shorten the answer this way. All right. We say the square root of 16, right? It's going to give me two answers, a positive 4 and a -4. So I write this as positive or -4. I'm sorry, 4. Okay, so that's how it's written. Okay, this is a long way of writing it. We just shorten it, positive or -4. And so the square root of 4 over here can be written as a positive or a -2. Right? Positive or -2. Now, sometimes the number you're asked to find the square of is not a perfect square. For instance, what if I ask, let me go to another screen. Let's see, let me add another screen. What if you're asked to find the square root of 5? Well, 5 is not a perfect square, all right? So we know that I'm going to get two answers. I'm going to get a positive square root of 5, whatever that number is, all right? 2 point something, so square root of 5. And also, I'm going to get a negative square root of 5, whatever that number is, all right? But I can shorten my answer, I can abbreviate my answer, I can write square root of 5, right? It's going to give me two answers, a plus and a negative, a plus and a negative square root of 5. Okay? Just remember that. Okay? Let's try another one. The square root of 7. Okay? Okay? That is not a perfect square. So I know I'm going to get a positive square root of 7, whatever that number is. And also, the square root of 7 is going to give me a negative square root of 7, whatever that number is. But I can abbreviate that. I can write the square root of 7 is equal to the positive and negative, right? Positive and negative square root of 7. All right, see that? So having done this, let's go back and solve this algebraically now. Now, if I want to solve this algebraically, x plus 4 squared minus 1. The first thing you want to do is you want to isolate the square term. All right? And so I have a -1 here, so I want to get rid of it. So what I'm going to do is I'm going to plus 1 on both sides. And so when I add, right, that's going to go away. And so I'm left with x plus 4 squared is equal to 1. All right? Now I have a square. I need to undo the square. To undo a square, I take a square root. Okay? For instance, 5 squared, right? To undo that 5, we know the 5 squared is 25. To undo the square, I take a square root. The square root cancels this 2, and that gives me 5. Square root of 25 is 5. So a square root, again, undoes or cancels the square. So let me go and erase this to get some more space. All right. So I want to undo the square right here. So I'm going to take the square root, right? I'm going to take the square root of x plus 4 squared. Well, what I do to one side of the equation, I must also do to the other side of the equation. Now, the square root is going to cancel this 2, right? They're going to cancel out each other, and I'm left with x plus 4 is equal to the square root of 1. Now, the square root of 1 is 1, but also negative 1. I'm going to get 2 answers. So I'm going to get square root of 4. I'm sorry, square root of 1 is going to give me plus 1 and also negative 1. All right? All right. Now let's simplify this. I'm going to have 2 equations now. I'm going to have x plus 4 is equal to 1 positive 1, because that's one of the solutions to the square root, right, of 1. And also x plus 4 equals to negative 1. So let's write this as x plus 4. Again, one of the square root of 1 is 1. And the other one is x plus 4 is equal to negative 1. And from here, I know you're going to solve this. I want to get x by itself. Therefore, I'm going to add a negative 4. I'm sorry. I'm going to add a negative 4 to both sides. So that's going to give me, that goes away now. So I'm left with x is equal to 1 and negative 4. That's going to give me a negative 3. And then on the other side, I'm going to add a negative 4. I want to cancel that 4, but also I'm going to add a negative 4 on this side. And so that goes away. I'm left with x is equal to negative 1 and negative 4 is negative 5. Now, look at on this side. You see it? These are the answers again. Negative 5 and negative 3, they're the same. So we solve this algebraically, and we get the same zeros, or the same solution, or the same root, or the same exponent. They're all the same thing. All right, guys? All right, so the square root is a new thing to you guys, so it's going to take some practice. Okay, let's try another example. Let's see what's the next one. Here it asks you to graph the function again, so I'm going to go back to Desmos, right, and graph this. All right, so let's look at Desmos. Let's see. Let me bring up Desmos. Here we go. Okay, let me clear this out, and we're going to graph now. I'm going to use y, okay? Y is equal to shift x plus 5 raised to the power of 2, and that is minus 3, okay? And that's what it looks like. Now, as you can see, okay, my domain again, it's going to be all real numbers. All right, my domain is going to be all real numbers. And my range, again, if you look at it, the lowest y value for this graph, right, is going to be -3. All right, -3. That's right here. That's the lowest y value, and all the y values are above -3. So my range is going to be y is greater than or equal to -3. And my zeros, again, the zeros are where the line crosses the x-axis. And that's going to be, let's see, well, this is -2. This is 3 right here, right? It's -3. So it's somewhere between -3 and 4. I'm going to run, okay, -3.2, all right? So from this, we're going to say it is -3.3 according to the graph. And the other one is -6.7. -6.7. Okay, so graphically, so that those are my zeros. All right. Let's solve this algebraically. So let's go back to uh, the slide and solve this algebraically. Let's see what we get. So let's fill this in. So we know the domain is all real numbers, right? I'm going to use that fun looking R, all real numbers. We know the range is y is greater than or equal to -3. And we know the zeros of the function are -3.3 and -6.7. Okay? And I guess I could try and sketch this. Let me see if I can do this. Let me make this a little bit bigger. Zoom in. Let's go to 200. So -3. Ooh, -3.3. This is 3 somewhere around. Oops, somewhere around there. And -6.7. I'm going to say it's somewhere around there. It's close to 7, but who's counting, huh? And then I'm just sketching. And my vertex is going to be -5. -3. So that's going to be my vertex. Let's find that. -5 is right here, and -3 is so right there. That's my vertex right there. So when I sketch this now, it's going to look something like this. Something looking like that. All right. So let's solve this algebraically now. Here we go. All right. So we have x plus 5 squared -3, and that is equal to 0. So again, the first thing you want to do is you want to isolate the square. All right, so therefore, I'm going to add a 3 here and a 3 there. So when I add, all right, that goes away, and I'm left with x plus 5 squared is equal to 3. Now let me zoom, okay, let me change back on to 150. 150, okay? So now, my next step now is, since I've isolated the square now, my next step is to cancel the square. And how do I do that? I take the square root, right, of both sides. So that's going to give me now the square root. I'm going to use right this time. The square root, right, of x plus 5 squared equals to the square root of 3. Everybody see that, okay? So on the left side, the square root cancel the square. So that cancels the 2 right there. So all I'm left with is just x plus 5 on the left side, and that is equal to the square root of 3. But we know that when we take the square root of a number, of a positive number, I'm getting 2 entries. I'm getting a positive number and a negative number. So I'm going to get a positive, right, and a negative square root of 3, whatever that number is. All right. So I'm going to have 2 equations now. All right. I'm going to have an x plus 5, which is going to equal to the positive square root of 3, again, whatever that number is, and an x plus 5 is equal to a negative square root of 3. Everybody see that, right? And technically, I don't have to write this positive right here because you don't have to. Now, we're almost there. I want to get the x by itself on each side. So I want to isolate the x. So isolate the x now, I'm going to add a -5 here and a -5 there. And so that's going to cancel out. So I'm left with now x is equal to, when I add these two numbers on the right side, I'm going to get -5 plus the square root of 3. I don't know what the number is. Okay? And on the right side now, I'm going to add a negative number against here and a -5. So a negative number, a -5 to both sides. And so when I add, that goes away, and I'm left with now x is equal to -5 minus the square root of 3. And I promise you, if you use your calculator and take the square root of 3, you will end up with these answers on the left side. Okay? So that's how we solve this algebraically. All right, let's try some more examples. This is what we have here. Okay, here it says use the square root method. Okay, and verify your answer by graphing with technology. So we can verify our answer by graphing. So let's solve number 1. Again, I want to isolate. I'm going to need more space. So I'm going to write over this. Okay, so I'm going to need some more space. Or maybe what I could do is let's do this. Give me a second, guys. Let me get my note sheet. Okay. So I'm going to need more space than what I have here. So I'm going to create a new page. So we're going to solve this x plus 4 squared, right, minus 7. We're going to solve this algebraically, and we're going to graph it to see if it's correct. So the first thing I want to do is I want to isolate the square, right? So I'm going to add a +7 here and a +7 there. So when I add, that goes away. So all I'm left with now is the x, stay with the blue, is the x plus 4 squared, and that is equal to 7. Now to cancel square, I'm going to use the square root sign. Again, what I do to one side, I'm going to do to the other side. So the square roots cancel the 2, the power of the square right there. So I'm left with now x plus 4 on the left side, and that is equal to the square root of 7. Now remember, the square root of a positive number is going to give you two answers. It's going to give you a positive square root of 7 and also a negative square root of 7. Okay, just make sure you remember that. So I'm going to have two answers. I'm going to have x plus 4 is equal to the square root of 7, and the other answer is going to be x plus 4 is equal to the negative square root of 7. Okay? And so again, now I want x by itself. So therefore, I'm going to add a -4 here and a -4 there. Now, and I'm left with now, that goes away. So I'm left with x is equal to -4 plus the square root of 7. On this side, I'm adding a -4 to both sides. And so that goes away. So I'm left with x is equal to -4 minus the square root of 7. Okay. And if you use a calculator and take the square root of 7, right? Just going to do 1. And I'm going to have you, let's see, what is the square root of 7? Give me a second, guys. 7, and the square root of that is, okay, give me a second. Okay, 7 square root. Okay. Oh, okay, let's try this again. 7, and that's going to give me 2.65. Let's call it 2.6, right? So that's going to give me -4 plus 2.6. And it's going to give me x is equal to -4 minus 2.6. And that if I add this, that gives me negative, um, let's see, -4. Negative. Oh, I am struggling on these new calculators. Okay. Okay, let's do mental math. That's going to give me 1.4. Yeah, that's going to give me -1.4. Okay, I just use mental math and that one. And x is going to equal to -6.6. All right. So we're going to graph this now. All right, on the Desmos and see if we get the same answers. My zeros are -1.4 and -6.6. Let's see if this is correct. I hope it's correct. -1.4 and -6.6. Let's see. Let's go to Desmos and see what we get. All right, bring up Desmos. Okay, let's erase that. We know y is going to equal to parentheses x plus 4 close parentheses power of 2, and then we're going to have a -7. Okay. All right, so let's see now. Let's see if that's what I get. All right. Okay. So I should get -1.4 or close to it, right? Let's see what this one is. -1.3, -1.4, right? If I run it off, -1.4. And let's see, the next one should be -6.6. Let's see if that's what I get. -6.6. All right, see that, guys? Awesome. All right. All right, so let's go back to the slide. Okay. Good. Okay. So this what I'm going to do now is I'm going to solve these, right? And I encourage you to pause the video. You try and solve them too, and then graph them in decimals and see if you get the right answer, okay? I'm just going to solve them algebraically, and you can graph them and see what it comes out to, all right? So number 2, okay, let me insert another slide for number 2, all right? Another slide for number 2. Number 2. Number 2 is, let me put number 2 right there. It is x plus 5 squared is equal to 0. As you can see from this, right, my x plus 5 squared is all by itself on the left side. So all I'm going to do now is just take a square root, right? Take a square root. And the square root of 0 is 0. So that is just 0 right there. And then on the left side, the square is going to cancel the 2. That goes away. So all I'm left with now is x plus 5 is equal to 0. Right? And so I want x by itself. Therefore, I'm going to add a -5 on both sides, and that goes away. So I'm left with x is equal to -5. Okay. So what does it tell you then? That the graph just touches the x-axis, right, at -5. It doesn't cross it, it just touches it. And you can graph it. That's what it looks like. All right. Let's look at number 3. Number 3, let me get another page. Number 3 is 2 times x minus 3 squared. And that's oh, okay. I did something here, guys. Maybe later. Okay, got it. That's not what I want. I'm sorry, guys. Let's see. How do I get out of this? Oops. All right. I'm just gonna leave it. I did something. The paper hit the screen, and that came up. All right. Okay. So let's continue, and that is equal to 10. So now here I have a 2 that is multiplied, that is times the x minus 3. So to get the x minus 3 by itself, I'm just going to divide both sides by 2. See that? And that goes away. So I'm left with now x minus 3 squared, and that is equal to 10 divided by 2 is 5. Now, to cancel the square, I'm going to take the square root now. So I'm going to take the square root, right? And that's going to cancel the 2 right there. So I'm left with x minus 3 on the left side, and that is equal to, remember now, I'm going to get 2 answers. I'm going to get a positive square root of 5 and a negative square root of 5. And so I write this as plus or minus the square root of 5. 2 answers. And so I'm going to have 2 equations now. I'm going to have x minus 3 is equal to the positive square root of 5. And I'm going to have the x minus 3 is equal to the negative square root of 5. See that? And to get x by itself now, I'm just going to add a plus 3 here and a plus 3 there. When I add, that goes away, and I'm left with now x is equal to, add these two together, I get 3 plus the square root of 5, whatever that is. And then on this side, same thing. I'm going to add a plus 3 here and a plus 3 there. That goes away, so I'm left with x is equal to 3 minus the square root of 5. Okay? Oh, this should be, okay. I like to keep everything the same. That should be blue color. Okay? And you can graph this in Desmos, and you should get the same answer. Okay? Number 4, let me add another page. Number 4, let's stay with blue. Number 4 is 3 times x plus 1 squared is equal to 12. Again, I want to isolate the square, right? So what I'm going to do is I'm going to divide both sides by 3. That goes away. So I'm left with x plus 1 squared, and that is equal to 4. Okay? Now, to cancel the square, I'm going to take the square root. Okay? Again, on both sides, the square root cancel the 2, and I'm left with x plus 1 is equal to square root of 4. Right? It's 2. I'm going to get 2 answers. I'm going to get the positive square root of 2 and the negative square root of 2. So I'm going to have 2 answers, 2 equations now. So I'm going to have x plus 1 is equal to 2, and I'm going to have x plus 1 is equal to negative 2. All right? And so to get x by itself, I'm just going to add a negative, oops, let's use the right color. I'm going to add a negative 1 here and a negative 1 there. That goes away. So I'm left with x is equal to, add those two numbers, 2 and negative 1, I get a 1. Let me draw a line here to separate these two. All right. Okay. So on the other side now, I'm going to add a negative 1 here and a negative 1 there. That goes away. So I'm left with x is equal to negative 3. So those are the solution. If you graph this equation, the graphs would cross the x-axis at 1 and negative 3. Okay? Now, what we're going to do is you're going to find some questions on the STAR test. And let's see. Okay? And so you'll see the STAR. This is how it's worded on the STAR. Right? This was taken from a couple of years ago. And it asks you, what are the solutions to x plus 7 squared equals 81? Again, all they're asking you is just to find the value of x. That's all you gotta do, right? So when you see something like this, right, you're just gonna take this again. You want to cancel the square here. So what I'm gonna do is take the square root of x plus 7 squared, right, equals to the square root of 81. Remember, you gotta do what to one side, you gotta do the other side. When I do that, the square root cancel the 2, so all I'm left with is x plus 7. But on the right side now, the square root of 81 is two numbers. It's a positive 9 and a negative 9. A positive and a negative 9. Okay? So I'm going to have two equations now. I'm going to have x plus 7 is equal to 9, and x plus 7 is equal to negative 9. I'm going to add a negative 7 to both sides. Okay, and so that's going to give me, that goes away. So I'm left with x is equal to 9 and negative 7. That's a positive 2. Okay, let's look at the other side now. I'm going to add a negative 7 here and a negative 7 there. That goes away. I'm left with x is equal to negative 9 and negative 7. That's a negative 16. So let's see which one has that. A positive 2 and negative 16. Right here, Jay. All right. Again, when you see something like on EOC, all right, I want you to apply this technique to solve it. All right. Okay, let's see what else we have here. Okay, let's clean this up for a second. All right. Okay, here, same thing. What is it? What is a positive solution to the equation? All right. So remember, there's going to be one answer. One is going to be positive, one's going to be negative. So let's see which one is going to be the positive one. So we're going to apply the same principle. All right. We're going to isolate the x, the square term. We're going to isolate that and take the square root. So here we go. So we have 0. Oops. So we have 0 is equal to 1/3 x squared minus 3. So I want to isolate this term. I want this all by itself. So what I'm going to do, I'm going to add, what do you think? A plus 3 here, all right? And a plus 3 there. That goes away. So all I'm left with now is 3 is equal to 1/3 x squared. Okay? Now, you probably forgot this part down, all right? We did it a long time ago. I want to get x squared by itself, but I have a fraction there. Now, how do I cancel the fraction? Well, remember, we multiply it by the reciprocal, all right? So this is a fraction. So to cancel the fraction, I'm going to multiply both sides by the reciprocal. So 1/3. What cancels 1/3? 3 over 1 is going to cancel 1/3. That's a reciprocal of 1/3. But what I do to one side, I must do to the other side, 3 over 1. Okay? So, in fact, let me put it next to the 3 over 1 right here. Cancel out, okay? So that goes away, and I'm left with now 3 over 1 times 3. That's just 9 over 1, which is just 9. So 9 is equal to x squared. Okay? And so I guess I want to cancel this square, so I'm going to take, okay, I started off with blue. Let me be consistent, guys. So this should be 9 in blue. So 9 is equal to x squared. To cancel the square now, I'm going to take the square root. All right? That cancels the 2 right there. So I'm left with x is equal to the square root of 9 is 2 answers. It's plus 3 and negative 3. So x is equal to 2. All right? So it asks for what is a positive solution? Well, I'm going to get x is equal to positive 3 and x is equal to negative 3. This is the one they want. They want the positive solution. X equals 3, right? Number 7. Okay, let me erase. Okay, can I write this? Let me go to another page. All right, so do number 7. Okay. Let's see. Okay, so I hate to erase. So here we go. So 2 times x minus 7 squared is equal to 32. Okay, so let's go to another page and do this one. Okay, so this is number 7. Let's add another page. 7. 2 times x minus 7 squared is equal to 32. Okay, oops. Come on, close. That was easy now. Okay, let's see what the question asks you, what are the solutions? All right, so what are the solutions? So again, we're going to start with x, so let's go back and do that. Again, I want to isolate my square term, right? So I'm going to divide by 2 here and divide by 2 there. That goes away, so I'm left with x minus 7 squared, and that is equal to 32 divided by 2 is 16. Okay. Now to cancel the square, I'm going to take the square root of both sides. So that gives me the 2 cancels the square root. So I'm left with x minus 7 is equal to the square root of 16 is 4 and negative 4. So positive and negative 4. So I'm left with 2 answers now, 2 equations. X minus 7 is equal to the positive 4, and x minus 7 is equal to the negative 4. Okay, so I'm gonna add a plus 7 to both sides. I'm gonna add a plus 7 to both sides. And so that goes away, and I'm left with x is equal to 11. And on the other side, I'm going to add a plus 7 here and a plus 7 there. That goes away. So I'm left with x is equal to a positive 3. So 11 and 3 are my solution. So 7, okay. I hope that is correct. Let's see. 11 and 3. 11 and 3 are the solution. All right, guys, good. Okay, let's see what we have next. I think this is the last one. Okay, the function L is equal to 0.8 t squared, and it models the relationship between L, the length in feet. So L is the length in feet of a pendulum, and T is the time in seconds, right, of pendulum. Which value is closer to the period in seconds? Or pendulum that's 30 feet long. So the bottom line is they give you the L, which is 30 feet. So this becomes 30, and they want to find T. All right. Again, I'm gonna pause the video. You pause the video and try this on your own. All right. You're gonna solve the T. All right. So here we go. So we're gonna have 30 is equal to 0.8 T squared. Okay. Remember what to do? We want to isolate this T squared, right? I want it by itself. So therefore, I'm going to divide by 0.8, divide by 0.8 on both sides. Okay, 0.8, 0.8. So that goes away. And 30 divided by 0.8 is, let's see, new document. Give me a second, guys. Let me do this real quick. Enter. Calculator, enter, and 30, let's see, 30 divided by 0.8, and that is 37.5. So we have 37.5. 37.5 is equal to T squared. Okay? Now to find T, right? I gotta take the square root of both sides. Oh, I end up with blue. Okay. Square root here and the square root there. The square root cancels the 2, right? So I'm left with now T is equal to square 37.5. Let's see. Okay, let's see if I can find that square root of 37. Okay, a second. Okay. Calculator, come on, square root. I am having, okay, let's see, square root, come on. Square root of 37.5, and that is equal to 6.1. Let's go, all right? So we're gonna have two answers, plus or minus 6.1, okay? But now, so there are two answers. You have a positive 6.1 and negative 6.1. But remember, we can't have a negative time. So the answer is going to be T is equal to 6.1. Okay, so we use a positive time. All right, guys. So that's the class for tomorrow for today's lesson. Again, for the questions, just let us know. All right. Thanks.